So today's lecture is basically three parts, which is we're going to do some more file reading, but that will come after. I had a request from a student, which please, if this is the case, like if you are stuck in the homeworks or the labs, let me know so I can go over some of the painting points in lecture. Right, and now this is with Lab 6. I think that was already due, so I'm more than happy to go over it still to make sure that it gets done, or to show students who have. And because it was a split, like you could do one option or another, this might be relevant to some students or it might be new material for you, so that's interesting. But what I wanted to go over was the cache program from Lab 6, okay? So the cache program from Lab 6 is fairly straightforward, given a number of, I think it's like given the dollar and cents value, right? A floating point number like $5.25 or $1.21, right? Given, so given, that easy to read or no with the gray on black? No? Let's go ahead. Yeah, that's what I thought. It's easy for me here, but no. So, nope. Oh yeah, fluffy was always good. Given floating point number, e.g. dollar print number of coins returned. Okay, now this one, all right, so, and what I suggested is that we basically do this as kind of two parts, okay? Because there's a couple different tasks here. First was the task that you had to make sure that the input would be rejected if it wasn't valid, right? And then the second part was giving the actual number of coins, right? So, if you think about it, there are these multiple tasks. One is taking the user input. Another is checking if the program can be, can run it, like if it's an acceptable amount. And then another task is actually doing the problem. You can break those into independent tasks and test them. For instance, the big part of it is doing like this, num coins, given a value, right, the number of coins, right, for that value, give me back how many coins it's going to take, right? And typically when I need to do that, I can say coins is equal to, then return coins, right? Or I can make it, and so you can assume like, hey, the value I'm already taking in is going to work, right? Like here I'm getting past a dollar sign, and I know, okay, it's already being converted to a float, and I can already, I can write to myself, assume value is a float, and so I can already do this. I can go value times, I can convert it to cents, where that's value times 100, and then I can then cast that as an integer to make sure that that I don't have to worry about decimal points anymore, right? Because to move from dollar to cents, you multiply by 100. Make sense? Okay. And I can just leave that there and come back to it when I need to. Because the part of the problem that other people that a lot of people run into is that validation. We can also have a program, and I mentioned this in the hints, that you might want to make a function that says, hey, given a number, test if it's a float. Right? Test if this thing is a float, if something's a float or not. And when we are testing to see if something is true or false, it's always easiest to basically try and assume something and then disprove it. So here I'm going to assume that it is a float. I think it's easier to prove something it is not a float than it is to prove that it is a float. So I'm going to assume that it is a float because it's easy to disprove that. right? So, and now we can kind of, with this in mind, I can write the rest of the program, kind of the outlines of the program without any of it actually being done. What do I mean by that? Well, let's just assume that this is fully done. And I'm going to pretend that this function's fully done as well. Make sense to everybody? Just going to assume that these are done, that they're folded up and they're already done. Okay? So let's go with, text is equal to input. So here I'm going to write the actual bit of the program we need to. And I'm going to zoom it up here, forget about everything else, and say, hey, enter the amount of change. Or I can, yep. And then I'll say, I will return number of coins. And that's not too far off the mark. Right? There's a certain length of readability, by the way. I like this editor because it has this very thin green line here. That's marking kind of the comfortable reading spot in text files. And it's not just because it's that big. I'm using that big of a font. It's literally number of characters, which can be useful. So enter amount of change. I'll return the number of coins, and then we'll take that text, and I'll ask myself, while is float text, and while that's false, so I'll say, wow, it's not a float. Okay, while it's not a float, what am I going to do? I'm just going to keep asking again and again. Does this make sense to you that I'm just going to say, hey, I'm going to be lazy about this. I'm just going to repeat the same question until they give me a floating point number. Right now, by the way, I assume everything, right? I'm pretending that isFloat is done because I've made it abstract. I've kind of said, this part of the problem is going to go into this box and I'm going to do it, but I'm going to do it later. But for right now, because I wrote it in a way that it quote unquote works, in that it doesn't return an error, there's no bugs in it, right? It's just going to work not fully correctly. It's going to assume that everything is a floating point number, right? So what I can do is I can say that, and so I'll keep asking them until I get something that is a float. Once it is a float, I will say, hey, the value is, basically the amount of money they entered was this, and I'll convert it into a floating point number. Floating point number for the text, and then I will say num coins, give me the number of coins of that value. And I'll go ahead and do this the way I like to do it, which is total. In fact, yes, that's what we'll use. We'll use total over here. Right? Easy enough. And we'll say, and then we'll print total, value, requires requires total coins in change. And there we go. We have a program that quote unquote works, by which I mean I can do this now. I can run it up, and it says, hey, actually it doesn't because you made a mistake, you silly goose. Enter amount of change. I'll return the number of coins. Okay. Let's go ahead and say I want $2.10. And it gives me a wrong answer, but it gives me an answer. You see that, right? It gives me a wrong. So this is so I've taken a big task, and what I've done is I broke it out into smaller tasks, two big small tasks. A lot of these programs you'll find, oftentimes it's like big task, two big tasks, and then a single kind of outer task to run them both. And yeah, it's not going to fully work because, and let me add in a space over here to these. 1 second. Because it's not going to fully work because, of course, if I put in Apple, it's going to just crash because it can't convert it. Yes?
So, the way for like those raw functions that aren't connected, is float always returns true?
It's always going to return true, which is incorrect. It should return false when it's not a floating point number.
Our while loop won't be executed.
Yeah, this while loop is essentially not going to execute because it's always going to return true. But now I can work on that while loop. Without having to worry about, so either I can work on the while loop or I can work on the numCoins function. But I can do them independently of each other, and the computer doesn't, and it's basically, I'm not gonna I'm trying to prevent my code from becoming spaghetti. If you've played the game Factorio, right, there's this kind of idea of your engineering, if you're making these factory lines and they become too complicated, it becomes spaghetti. We actually use that same term in computer science with code, where basically the code just becomes so complicated and interconnected and you can't really figure it out. That's spaghetti code. It is too much. Then there's other terms for code, like code that you just keep in because you don't know what it does, but if you take it out, it changes stuff. So there's all sorts of terms we have in computer science. But the point being is that you do need this kind, but one way to prevent your code from becoming spaghettified is by breaking these tasks up into definable functions. Testing if something is a floating point number is a definable function. So let's think about ways we can prove that this is not, that some text is not a float. We can say, hey, something is not a floating point number if, here's an easy one. If the length of the text is equal to 0. If it's an empty string, it's not a floating point number, right? I can't convert that, so I'm going to say return false. I want them to actually give me something for the purposes of this program, right? Another kind of way to think about it is that it's not a floating point number if they give me letters, right? A floating point number won't have letters in it, right? I will boot up idle for just a second. Come on. What is going on with the search function? Oh my gosh, I was having issues on that computer on Tuesday when I was trying to show stuff, and I'm glad that the projector's working today. But here's some examples of floating point numbers, just to answer a few questions you might have in advance, right? This is a floating point number, 3.1. The question is, what about that period? Can it be anywhere we want? And the answer is pretty much yes, right? Humans sometimes write, instead of saying 0.31, instead of 0.31, sometimes humans will write 0.31, which just gets converted to there. Similarly, we have 1.0, right, as a floating point number, which is 1 as a floating point number. But what about 1 point? That's much less rare. That's much more rare, but it's still valid. Okay, so the point can be anywhere so long as there's only one of them, right? So let's think about this. What are valid characters that we care about for a floating point number? These characters, the numbers, and the point. We're going to ignore that negative floating point numbers exist. You can have negative numbers, but for the purpose of this program, right, you can't, we don't want to give back negative change or something like that. That doesn't make sense. So we're just going to say if it has a negative, it's obviously not valid. Okay? So what we'll do is we'll make a string of valid characters, or we'll list them in a string. Valid chars is equal to, and then this is great. You can just kind of slide your finger across the keyboard and get all the numbers. It's wonderful when you can just type it out like that. And then we'll say the point as well. And we'll say, hey, if it's not, and we just got to think to ourselves how to put this in Python. If it's not one of these characters, if the text has something that's not one of these characters, it's not a float. So what we need to do is just check every single character. For car in text, if character not, and we can just simply say not in. It's so nice to do that in Python. If character is not in valid cars, the autocomplete function, I like Geany because the autocomplete function is extremely limited. It's limited to stuff you've already typed in the document. That's it. So it's not giving me any additional hints that you would get in, like, say, VS Code. It's a very minimal text editor, like extremely. So for car in text, if character not in valid characters, I would not use it in production, but for pedagogical purposes, this is perfect. If the character is not a valid character, return false, right? If it's not, we look at a character and say it's not one of these, we're going to return false. A common mistake that a beginner will make is to say else return true, because if there's an if, there's got to be an else. And if it's return false, then you got to return true. But if you think about it, you take a look at the first character, you say, oh, it's not invalid character. Sorry, is it invalid characters? It's invalid characters, so this evaluates to false, so we go to the else, and then we return true on the very first character. But if we return true, returning stops a function. It ends the execution of a function. Returning means we got our answer, let's give it back. So that would basically make it stop immediately. Finally, there's really only one other thing we need to care about, which is if, and this is kind of pedantic, if text.count, if I count the number of periods that occur, and that is greater than 1, in other words, if I have more than one period in my input, then that's not a floating point number. Floating point numbers only have one period in them. They only have one floating point. So return false. So, for example, now I can now run this, and if I say apple, it's just going to keep asking me if I just keep putting in random text. If I say 1.2, it's fine. It gives me the wrong answer right now, but now the input's guarded. It's not going to crash. Similarly, if I do this, if I do 192.168-0-1, which is an IP address, right? It's your home. It's the kind of marker for this is the computer I am using, or something similar. Then it will give you an error.
Wait, what happened? What about, like, what if they input, like, more than, like, 3 characters after the dot?
I mean, if it's after the dot, if it's got spaces in it, it's not gonna have, spaces aren't valid characters, right? But again, it doesn't really matter how many, if it has more than one dot, it's gonna error because we're counting the number of dots. Make sense? The code over here says, hey, if it's empty, it's not a float. If it's got something that's not valid, it's not a float. And if it's got more than one period, it's not a float. If it doesn't have a period in it, that can be cast into a float. That's fine. If they enter an integer, that's fine. Make sense? We're just trying to guard our input here. And now I can work on this part without having to touch anything else. Right? Now, the way this part works, okay, is kind of a classic algorithm, and I'm not going to go over that because I don't want to do the entire program for you if you still need to do it. But the way this one works is fairly straightforward. What we've done here is we've calculated the number of cents, and you're trying to figure out how many, what is the minimum number of coins you need to give out. Okay? So what we've done over here is we've calculated that into cents because we've got quarters. I think we were just using the 4 coins in the US, which is quarters, dimes, nickels, and pennies. Okay? And the approach you use is something called a greedy algorithm. A greedy algorithm is something you'll get into much later, but it's it's a lot of times the best answer, which says the best overall answer, the most efficient answer, is making the most efficient answer right now. Now, there's a lot of times where making the most efficient answer right now does not produce the best answer, right? Like, for instance, in chess, if you try to make the move that maximizes your position right now, you're only thinking about this move and not moves ahead, which can really, and then you can be outplayed by somebody who's thinking multiple moves ahead. That's the kind of area where, so you can kind of get a glimpse into where greedy algorithms might not be the best idea. But for things like this, what does that mean here? Well, what we're going to do is that we will basically look at the total number of coins we have, and we're going to subtract the amount of coins that I need. Or I could use modular arithmetic and division if I wanted to be really fancy. But basically what I'll say is, while cents is greater than 0. And then I can kind of go through, there's two ways to do this. You can say, while cents are greater than 0, okay, and then go and say, can I subtract a quarter out of this? No. Can I subtract a dime out of this? No. What if I subtract a nickel? A penny? And then you just keep doing that over and over again. The other way you can do that is greater than or equal to 25. Yeah, isn't that fun? Ligatures. It's part of the reason I also like text editors like these. I can start taking advantage of ligatures. So while cents are greater than or equal to 25, meaning I can remove a quarter, and then you do remove a quarter. And every time you remove a coin value, you add 1 to the total. So that is kind of where we go with that. I can dump this onto our Discord later, okay? For now, though, I want to talk about I'm going to go and jump to lab 7, which is the IRMA. Now, I didn't get really the chance to do this, to really go into detail about this last time. So I'm going to open it up, and we have this data folder over here, okay? And we have this thing called irma.csv in it. So let me explain what is a CSV file. CSV stands for comma-separated values. It is one of the, and if it is a perfectly valid file format. Let me go ahead, and it's a common one. Can I show? Okay, yeah, it doesn't let me open. You know what? I will copy location. If it's on my desktop, what was I trying to do? I guess not. It's in documents. This is why you should see. I'm doing what I told you not to do. Always know where it is. So data, right over here. And if you notice, I guess I don't have Excel. I don't think I have Excel installed on this. All right, normally if you have Excel in your computer, opening this up will open it up in Excel, because that's what CSV files kind of are generated with a lot of the time, Microsoft Excel. These are meant to be kind of a table where all the values are rows and these are columns. The columns are separated by commas. Make sense? So here we have the date. So here we have the legend. A date, a time, a latitude, a longitude, a wind, and a pressure. Okay? So we have August 30th. We have the time, which is GMT. These are not really going to be relevant because it's in chronological order already. Then we have the latitude and longitude. This is where the hurricane will be. So negative 30.3. It's already converted to negative for us. Like east is positive, west is negative, north is positive, south is negative. We've got a wind speed and an air pressure. Make sense? So what your goal is to do is to read this file, move the hurricane to this latitude-longitude combination, and then color it appropriately to how strong of a hurricane it is. How do you know how strong a hurricane is? I mean, I don't know off the top of my head. And the answer is, you look it up. Hurricane strength. And we can just go to Wikipedia or for this, but we've also got the National Hurricane Center, which is perfectly suitable, right, for this, right? And what we use is the Saffir-Simpson Hurricane Wind Speed scale, which is different than the tornado scale. Every kind of natural disaster has its own scale. Yes, Fujita scale for tornadoes, Richter scale for earthquakes, Saffir-Simpson hurricane scale. This is what we use in the U.S., by the way. Other countries may have different ones, but over here we can see one sustained winds 74 to 95 miles per hour, 64 to 82 knots. So more than likely this CSV file, given we see a low of 50 and it goes with Hurricane Irma, it goes up to 185, and that was a very bad hurricane. That we're looking at miles per hour, right? And just to kind of confirm our suspicions, Hurricane Irma was an extremely powerful and devastating category 5. So, to strike Leeward Island. So it was category 5. So definitely our units are miles per hour. So based on what the wind speed, where the wind speed falls, you would basically have an if statement to figure out what the color was. If it's greater than 157, do this. Else if it's greater than 130, do this. Else if it's greater, and that else if is important there because then you don't have to build the range in. You can if you want to. But we need to read this file first. Okay? And what I'm going to do here is I am going to I'm going to show you what basically where most of you get stuck, and I'm going to make you unstuck because again we have spring break. So we want to read this file. Now you may remember from last lecture if you were here, but of course last lecture was a bit foobar. So to open a file in Python is very simple. You just simply give it the file name, or the file path rather, irma.csv. Because it's a CSV file, so we say .csv. That's the name. So the extension is part of the file name. And then what we do is that we do a comma and then an R. And I never did explain what that R was. So to open a file, you have different options when you open a file. You have R for read, and so you can kind of guess what a W would be, right? A W would be to write the file. That's if you want to write stuff into a file, and we'll get into that later. And then finally, you also have append. W writes a new file from scratch. Append takes a file that A would, so if this is writing a file, and append would take a file not from scratch and just add to the end of it. So if you wanted to open up a file you've already worked with. Most of the time you're doing R or W. In this class you'll be doing R a lot. So irma.file, and we say we want to open it in read mode. Yes? R is to read a file, and then, so in other words, to look at it. W is to change it, or to create a new one. Okay? Okay, and so we're going to go ahead and open this and say data. And then let's go ahead and print it out. Print out the data. Why not? And we run it, and we get an error. It will say, file not found, no such file, irma.csv, which is bad because that would be an instant 0 if you were demoing it. Now, but you're like, but there's a file here. It's called irma.csv. But the difference here, we can see over here on the side in our file starter folder, okay, or starter file folder, we've got irma.py, and I mentioned this on Tuesday. Irma.py is here. but the irma.csv is not, right? So you could think, and some students do this, where you just simply take irma.csv and you copy it out to here, and then you run it, and it works fine now because you can see the file. But that's really not what we want to do. So you can see the file now. That's really not what we want to do, though. We want to read the file without having to change the file structure at all. Okay? And we get how to do this by looking at the rest of the, whoops. We get the Control Z, gotta love it. We fix this by looking over here at the rest, which is where it gets the image for the Atlantic Basin. It opens it up using not open, but by using a file path, and it says images/Atlantic Basin. Images is another folder that's located in there. So I mentioned this yesterday, or not yesterday, but to get inside, but what you want to do to get inside a folder is you give the name of the folder and then slash, assuming it's a folder in the same location. So we would go data/irma.csv. Make sense? And now it prints it out and it closes as soon as it's done. If you don't want to, if you're using idle, it's going to stay open. Here, it might close and you might find that annoying. If you don't want it to close immediately, we just add a turtle.done. And now it's not going to move on until I close the window. And again, I showed also yesterday that we could easily move this by, here I'm going to change the name of, we've got a turtle here, its name is T. I'm going to change him to Bob because it's just, we've been using Bob for a while. And we can move the turtle by just saying go to 20, I think it was like -80, 21. And you can see basically the turtle move by using the go to. So that's how we're going to make the turtle move. So what do we need to do for this? Well, we will open it up. So we've got our data. Now I could read it all at once, but what I'm going to do is I find easiest to do this is .read lines. And this gives, and I'll say lines is equal to data read lines. Print lines. And that gives me all this, which is gross, right? So what I'm going to do instead is I'm going to say, but what this does is that it's made a list. Lines is a list of, and it's a list of all the text in the file, where every line is a string. It's an item. So the first line is so this is index 0, index 1, index 2. Each line is individually stored. So we'll iterate through it rather than dealing with it all at once. 4, line in lines. And I like to do that. 4 singular and plural. Some of you hate that, and that's fine. Don't do it otherwise if you hate it. And I'll just print out lines. Not lines. We'll just print that out again and again. Print line. And now we'll see, hey, we're reading the file and now we're printing it out. And now, because we're working with each line, we can start manipulating it. Okay? The other thing I'll mention is that we do want to get rid of this first line because this first line does not have data. It has legend in it, and I don't want to modify the original file. So you can just use a slice to get rid of that. What do I mean by that? From 1 to the end. And now I don't have to deal with that, right? I'm reading the entire file except for that first, I'm going over that file except for the first line. The rest is up to you. For the most part, you might have to look up how to write some text with Turtle. But once you put this together, it is actually remarkably, you're going to be like, oh, this remarkably isn't that complicated. Yes?
I'm getting the name error and name data is not defined.
Did you do this over here? Date?
I'm good.
Okay, cool. Question, there was another question? Yes.
I'm getting Erno to a dosage file or directory.
Okay. Are you working on VS Code?
Huh?
Are you in VS Code?
Yes.
Are you using, what are you using, idle or code?
I'm using idle.
Okay. Make sure that basically you're working on irma.py inside the starter folder. Are you?
Yeah, I assume it's.
Right. You want to make sure it's not you didn't accidentally pull it out. You want to make sure that you've opened irma.py and the file structure looks like this. Right? It looks like this. With that, and it's not, and irma.py isn't hanging out somewhere else. I'll be happy to take a look at it after class. I want to make sure I have enough time to go through just file reading in general, because this next part is kind of relevant about how we're going to do stuff. Okay. So my kid is finally getting comfortable with reading, which is great. You're wondering what this has to do with the lecture at all at this point. I know I go off on wide tangents, but it's great because he's finally picked up one of my favorite games, Pokemon. When I was in, just to kind of date myself, I was in elementary school when the first Pokemon Red, Blue came out. So, and I remember reading about it in the Nintendo Power magazine about the game when it was, currently being developed and released in Japan, and I got it basically as it came out in the U.S. and I had a lot of fun with it. So I haven't played every single game that has come out. In fact, I haven't even played the most recent one because it's an itch to scratch every so often. These days I'm into other stuff, but I do occasionally have fun with the competitive scene there. Even though I say I have fun, I'm not that good. I play with the Pokemon I like, not what's going to necessarily win me a tournament or anything. So, but the nice thing about Pokemon is that it's a very data-driven game.
It's not like, it turns out it was like,
So, anyway, back to that. So, fortunately, Pokemon is fairly robust in their stats. And what we're going to do is that we're going to work through this as kind of an exercise, because we need data, and let's see. And I have this already here, and like, again, it's a very well explored game, like saying, okay, how you can determine how HP is determined based off of other stats and IVs and EVs and other things like that. HP stat, and then let's see. And I go with Pokemon by stats. Let's see. Category, list of Pokemon. Base stats. New generations. List of Pokemon by base stats in here. So we have this, and this is a nice big table for us to use, in other words. Let's see, can I just... Whoops. And yeah, that worked. And I can just simply start. And what I did to just grab everything, by the way, is I went to here, to Bulbapedia. I just grabbed this. And you can do this with any table that we're going to be doing, but I like Pokemon because for those of us who have played, it's very fun. I haven't played the latest batch, but then I used Shift and click to basically select everything. let's see, can I just simply move it into here? I already have a file set up if I need it from last semester. And new, and I got it somewhere else, but I'm gonna go ahead and just use this. We can also just simply look for a Pokemon.csv file, but I'm gonna go ahead and use this one that I downloaded a while ago, just so you won't be able to necessarily follow along, but you can, other than on the screen, but it's fine. I've got this CSV file over here of basically a list of each of the Pokemon. First line is basically basically the legend. The ID, every Pokemon has a number, a name for the Pokemon, and then the form. Some Pokemon have alternate forms that they've added on, like just simply so that they could like reuse old Pokemon and give them a new spin. Pokemon have types, which basically the entire thing about Pokemon is that it's a giant rock, paper, scissors game, where basically some types beat another. That's kind of the attraction of it, and trying to outthink your opponent. And then we've got all these numbers over here. I'll start with the last one, which goes up 1 through, and then up all the way over to here 9. These are what's called the generation. We won't really need that, although we can use it later on. But that's basically when the Pokemon was introduced. Okay, kind of new Pokemon are kind of introduced all at once as part of a generation. And so so they've done that now 9 times. The rest is basically the stuff you would care about it for any RPG, role-playing game. Okay? Which is HP, which is short for hit points, basically the amount of energy or life a character has, or health. Typically, HP can be, depending on your system, it can represent health, with 0 being dead, or 0 in some cases, in this case, being unconscious. Then, if you play Dungeons and Dragons, you're familiar with the stat. And then you've got the other things. You've got attack, defense, special attack, special defense. Basically, is it physical or is it some kind of energy attack? Speed, which dictates who goes first. A relative way, an okay way of eyeballing how good a Pokemon is by looking at their stats, but that's not everything. For instance, let's go ahead and look at Mewtwo. Notoriously one of the strongest Pokemon. He has a base stat of 680. That's very high. If we look at, though, one of my personal favorites, Slacking, he has a base stats of 670, which you would think, oh, that's great. He's a very strong Pokemon. And he is on the turns he's awake for. Well, or not slacking off. That's kind of his thing. He only decides to play every other turn. So it's not just this. It's more than just this rock, paper, scissors game. So we can ask ourselves, so we can do kind of some basic analysis of these stats, because this is a CSV file. It's a comma-separated value file. Right, and you can do this for any kind of CSV file. It is linked to, I do have this on my GitHub. So if you go to Canvas, you'll actually be able to look at my GitHub if you haven't seen it yet. This is a place, you'll learn about how to use GitHub later in this semester after spring break. But I have a few repositories, including Classroom, which is where I try to remember to put all the code. Intro, and you'll see that I have this over here, Pokemon CSV, as well as a bunch of other stuff that I've created. And so if you really want to download the file, you can find it over here in my GitHub. My username is abrosen. Okay. Now, so we've got this file. Let's go about how we actually read it and use a CSV file, because you're working with a CSV file in your homework, right? So, and you want to extract certain values from that CSV file in your homework. So let's go over an example about how we read a CSV file and extract values from it. So I'm going to create a new file, which is, let's say, I'm going to create it. I'm going to say documents. Got to make sure it's in the right place. So GitHub. classroom, intro, Pokemon CSV, I'm just going to call it Pokemon CSV example. And I would just, .py, and I would just watch along. So first thing we want to do before we decide to do anything with it and kind of look at interesting things in it is we will look at just reading this file and going through it. So first thing we want to do to open the CSV files I've showed you previously, but repetition is key here. Open, and I called this Pokemon with a capital P .csv. And in case you're wondering where that name comes from, it comes from the Japanese name Pocket Monsters. Okay, because they're monsters you can keep in your pocket in your Pokeballs. So, Pokemon.csv, and this is all, I like to call this the data. And then we can go through and then we can test by saying lines, or we could say, or we could redo data. We could say data is equal to data.read lines and replace that file reader with a bunch of lines. And it doesn't error out, except it does because I accidentally have a string here. Oops. And it doesn't error out, so that means it worked. So print data, and it's just gonna go whomp, right? But now the data's in here, and I can go through it. Okay. Now, let's go ahead and kind of decide what we want to do. What we're going to do over here is that I think let's go ahead and figure out which Pokemon has the highest HP. Okay. Now, some of you might know that, but some of you also who aren't familiar with these video games and their jokes might be surprised. So, we'll see. What we'll do is, and so we want to figure out which of this column has right, so we've got the total stats and then we've got the HP. So we want to figure out how to get that. Now, the thing about CSV files is that they're very structured. Every single field is separated by a comma, which means we can use some of our Python knowledge to get this. Each line is stored as a string, and each string is made up of pieces separated by commas. So what we'll do is we'll say for line in data. Let's go ahead and print the line just to kind of show where we're at. And we can see that we're printing it line by line as we can go through one at a time. Now, I can't just simply say, oh, I need to grab characters like 10 through 12 to get the HP stat, because every Pokemon has a different length of name, all the types have a different name length, so that's just not going to work going character by character. And it would be painful to have to count, okay, let's see. So HP is this one, so I'd have to going through and counting 1 comma, 2 commas, 3 commas, 4 commas, 5 commas, 6 commas, going through and saying, hey, I've got to count 6 commas before I get to the, it's whatever the number is between the 6th comma and the 7th comma. That's doable, but it's a pain in the butt. Don't want to do it that way. Instead, what we're going to use is we're going to use the .split function that we've seen a couple times here. And just to kind of show you, I'll go this into, I'll say parts is equal to line.split. And you got to say, what am I splitting on? And I'm going to say, you're splitting on a comma. And what a split does is that given a string, it turns it into a list, where each part of the list is an individual string. I know that seems weird. We're taking a list, turning it into a string, going through each string inside that list and turning each of those strings into other lists. But simply put, we're just taking a big thing, breaking it into smaller and smaller parts. So for instance, we over here can now see, here's Machamp, and rather than dealing with one big string, we have our first string, our second string, so 0, 1, 2, 3, 4, 5, 6. So index 6 gives me the HP. Make sense? So I could say, here's our part, and I could say HP is equal to parts 6, and then I'm just going to count, and then I'm going to just simply cast that as an integer. And then rather than print, and now I can just simply grab the name. The name was index 1. And now what I'll do is I'll just print out the name, comma, HP, and suddenly we see, oh, it's a lot easier to kind of look at this. Oops. Invalid into, oh, huh, what? No, this is mock surprise on my part. Saying what? Invalid literature for int, invalid literal for int with base 10 HP. Well, if we look in the CSV file, we see that we're reading this, and we're trying to convert it into an integer, right? So remember what I said back in irma.py when I was talking about the homework? Oh, you want to throw away that legend, right? We want to do the slice. That's why, because the legend has stuff that I might want to try to convert and it's getting in the way of me converting stuff. So what we do is that I'm just going to, again, get rid of that first thing, or if that annoys you, we can just simply do this over here. Data is equal to data from 1 to the end. Remember, this is a slice. This means to the end when we have it blank. And this is the starting index. And this is saying I want everything starting at index 1. In other words, I want everything starting from the second line. And now I can run it. Oh, and I misspelled, of course. That's fine. Reading the error explains the error a lot of the time. And so now we've printed out every Pokemon and their HP stat. Now, how do we find the one that has the biggest, right? That's not too hard. We'll simply say the biggest is 0, and we'll say, hey, if HP is greater than biggest, then we'll say biggest is equal to HP. And then we'll print out, and then when we're done, rather than going and printing out the entire thing, we'll print biggest. All right, and we run it, and we get that the biggest HP value is 255. That doesn't tell us what Pokemon it is, though, which we'll get to. But 255, why is that? Because this is a game that's based off a game made for the original Game Boy. And in the original Game Boy, that was an 8-bit system, meaning a stats value could be represented as an 8-bit number. 8-bit numbers, their range is 0 to 255, right? 2 to the 8th power. There's 256 different values. So if you start at 0, then those numbers go from 0 to 255 inclusive. So this is basically saying, hey, the biggest HP, it was maxed out. Interestingly enough, we can kind of just simply do this. We can use a tuple, or a list if you prefer, and I'll do a list because we're more comfortable with lists at the moment. But tuple is basically just kind of a list you're not going to change the values of. So biggest is bum, and then I could store it like this. You know what? I'll do it the way you typically do it on an exam. You would do it typically, which is I'll keep it as a separate variable, and then we'll do, for the next part, I'll do a more interesting thing. So biggest, let's go with biggest name. is equal to empty string. And now what we'll just do is that we'll saying, hey, if the HP is currently bigger than the biggest, we'll go with biggest name is equal to whatever the name is. And now we can say biggest, comma, name. All right. And biggest, and we can run it, and it will give us Blissey having 255 being its with the biggest HP value, which surprises no one who's actually played Pokemon. Yes.
So I have a hard time following. I tried to run it and I got an error that says this index out of range. I'm not sure why I haven't.
Which one are you? I'm not sure why you're getting an index out of range. Did you do these parts first?
No.
Right, so just watch along rather than trying to do this because you do need the file. Now, as I was saying, this comes as a surprise to no one who's played Pokemon that that Blissey has the highest HP, which, of course, this being Blissey, this is definitely the Pokemon you'd expect to have the highest HP of them all. Games are fun like that. Let's actually go. So let's go ahead and say maybe, okay, rather than getting the one with the highest HP, let's go ahead and look at maybe the top 5. So how would I do that? And that's actually a bit trickier. Because what we'll have to do is we could keep track of like 5 variables. We could also try to sort this, which is typically what you would do in a real scenario. You'd take this and you'd sort it by HP, but that would require, that's very language specific, shall we say. The solution to doing that is very language specific. And I'd rather like puzzle it out with the tools that we have. So one way I would do it is maybe, I'll maybe call this HP list. Or maybe I'll just lowercase this HP list. And it's a list of 5, and it's a list. And what I'm going to do is I'm going to say I want to find the Pokemon with the 5 Pokemon with the largest HP. So for blank in range, I'm going to do this 5 times. I'm going to HP list dot append, and I'm going to basically say I'm going to create what I'm calling a blank here, which will be this, a tuple, basically a pair of values rather than one value. You could easily do this as a list, and the syntax is going to be exactly the same. It just looks easier on the eyes if I do it with the parentheses. An empty name and a number. Okay, and then I'm going to add the blank to the list. And then what I'm going to do, rather than at the end, is I'm going to print out rather than printing out this, I'm going to print out the HP list. And so how is this going to work? I am going to use list functions to my advantage here. So, for line in data. For every line, rather than comparing it to the biggest, what we're going to do is that we go through, we grab the HP and the name of every Pokemon, and what we're going to do is that we have this list of Pokemon that have the highest HP value. And what we've got is they'll have a name, and they'll have their number for that. There's 5 of them. So we'll say for blank for mon in HP list. So for each Pokemon in the HP list, what we're going to do is we are going to, let's break it apart, is we are going to get the name, we're going to go ahead and say other HP. And this is probably the part that's going to be most confusing, is equal to mon 1. Why? Because this tuple, which again I can always render as a list instead, this tuple is a list, or this list has two values in it. Index 0 is going to be the name, index 1 is going to be the HP. And what we're going to do is that we're going to go through the list. And as soon as we find a Pokemon that we have more HP, then we're going to insert ourselves into the list and bump one of the entries in the list out, the lowest entry in the list out. Okay? And because we're doing it in the way we're doing it, it's actually going to be a sorted list whenever we go through it. So we say, hey, we're going to get the other HP of that Pokemon if HP is greater than or equal to other HP. Actually, it's the other way around. Nope, it's not the other way around. If our HP is greater than the other HP, what we're going to do is we are going to say, we're going to say me, this current Pokemon, or this mon, is equal to, and we're going to create another name pair, HP pair. Basically, we're just storing, we're taking two variables and we're stuffing them into one variable. That's what this does. It's the same thing as a list conceptually, or in effect, although conceptually they can be used differently. Anyways, the only reason I'm doing it like this is because it's going to be easier to read and we don't have to deal with double parentheses. This mon, and then we're going to say HP. Oh, where do I insert it? That's right. Give me a second. What we'll do is we'll say HP list dot insert at an index this mon. We want to put this Pokemon into the list at some index. And then what we'll do is that we will say HP list is equal to, because we're going to keep it from getting bigger than 5, we'll just simply say, and only keep the top 5 values. Right? This will create a 6th value, and I'm saying slice off the last value. Is everybody following so far? Kind of, sort of? No? Yes. Sorry? Yes, I'm gonna put. I mean, the code's already up. I'm gonna post the code and the and the recording because I couldn't do the recording last time. So here, right? This is just a single variable that has 2 variables in it. List. So what I'm doing is I'm saying grab the HP from the HP. If my HP is bigger than this person's, I'm gonna bump them down in the list and take his place. That's what this does. Now the question is, where in the list do I go? I've got a very handy thing here called enumerate, which I'll show you. It should be enumerate. There we go. What in the world is he doing? Right, so we're going to go ahead and just comment this out for a second so I can show you what I'm doing. Okay. Enumerate is super useful. I'm going to go ahead and make a list called L. It's going to have the number, it's going to have A, B, C, D. You get the idea, right? It's just a list. I just needed a list of some kind, and I'm not using numbers because I want this to be easy to read. And what you can do is you can do 4, right? I could do 4 letter in L. Print letter, right? And it will print out A, B, C, D, right? Sometimes though, and then often, a lot of times sometimes we care about what index things are at, in which case we would do something like for index in range, right? we've seen this before, in range length of L, and this is actually very close to what you have to do in other programming languages, and you would say letter is equal to L index, right? Give me all the indexes from 0 up to, but not including the up to, but not including the length of the list. In other words, all valid indexes. I'm going to grab the letter at that index, and then I'm going to print that value, right? But this is clunky looking, right? Python, though, is an extremely flexible language. And what goes in here, I've always said it was for thing in collection. But it's actually pretty fun that you can do for things in collection. You can do this, for index, comma, letter, in enumerate L. And what this does, when you do enumerate, it's a nice, it's one of those things you don't always need to use. In fact, you don't use it much of the time, but when you do use it, you're like, dang, that's useful. What it does is that it gives me the index and the thing at that index at the same time. It gives me both without having to jump through any hoops. So over here, when I do this, let's go back to commenting this out and go back to our HP list thing. So delete one, delete this other one. So what I'm saying over here is for the index and the thing at that index in the HP list. So now I know where I'm going to put it. I'm going to say, hey, if the HP is greater than the other Pokemon's HP, then I'm going to replace the other Pokemon with this current Pokemon. Sorry, I'm going to bundle up myself. I'm going to take this Pokemon and pair and bundle it up into a name HP pair. I'm going to insert it into the list. Make sure the list only has 5 values in it. HP list is equal to HP list. Slice like that. And then what I'm going to do over here is I'm going to use have you seen this word before? Break. Should have seen it in your textbook by now. It's useful at certain points, but what break does, it says, hey, I'm in a loop, break out of the current loop I'm in. I might be in multiple loops, and if I am, I only want to break out the innermost loop I'm in. Basically, it says, now that I've found a place to put in the Pokemon, I can stop. And so then we look and we see we've got a few different Pokemon that have, which Pokemon do have the highest HP. Eternatus, which is like a cheat Pokemon, 255. Blissey, 255. Chansey, which is the pre-evolution of Blissey. Chansey's turn into Blisseys. Guzzlord, 223. And Zygarde, another legendary, at 216. So we can see, basically, here we have the top 5. We can also switch it up. Let's go ahead and find maybe the top 5, let's say, buffest Pokemon. And we can define that as which Pokemon have the highest attack, defense, and HP combined. How would we do that? A very similar way. What we do, right, if we have multiple variables that we need to grab, we just kind of go and try to grab those variables. So for example, we've got our HP. Attack is the next stat, int, parts. And I just know that from looking at that chart and remembering. But I would count physically otherwise. And defense is equal to int, parts, 8. And now I would say basically, I'll call it buffness, right? For how basically combined strong they are. HP plus attack plus defense, right? And what we'll do is now, rather than comparing their HP, I'll say other buff, which is going to be 0. And I'm just going to replace basically my stuff. And I call it HP list still. I'll keep it that way, but I could change the name. And we can run it, and oops, int parts. What was that error says? It says it was never closed, right? Everybody see that? We can close it. Eternatus, Groudon, that's not surprising, Aggron, basically Pokemon made of Earth, Pokemon made of Steel, other Pokemon made of Steel. So overall, you can see how we can just grab pieces of the data. So what is relevant for doing your homework? Because we are almost done with the lecture, and this is kind of the important part, right? The important part is doing this, the dot split on the commas when you're operating on the CSV file, because that enables you to work with every single row in the CSV file. 4 line in the data, split on that line. And then you can extract the parts as you need to. Remember, if you're working with numbers, you want to cast those numbers into, into integers or into floating points in the case of your Irma lab, right? And then based on that, you do this. You can kind of start to see the picture, the altogether portion of this. For your Hurricane lab, what I recommend doing is first making sure you can read the file and print it out. Next, what you should do is you should focus on getting the turtle to move to each location. So before that, you probably need to get the latitude, longitude. So you should split, print out, basically focus on what I want to do is get the individual latitude and longitude and print those out. Print out that you were getting the latitude and longitude. Not the whole line, just the latitude and longitude. Once you know you're getting the latitude and longitude, have the turtle move to that latitude and longitude. Except remember that latitude is your Y direction, longitude is your X direction. Or is it the other way around? You want to double check. And then once you, and the way you do that is you aren't using you aren't telling the turtle to go forward in this case. You're not telling turtle go forward, turn back, left, right. You're telling the turtle, hey, Bob, you should go to this specific XY coordinate. Once you do that, then you can work on changing the color of the line to indicate how strong the strength is. It's kind of so don't try to do it all at once. That way is going to get you very stuck very quickly. Instead, focus on doing your code basically just as in a piece at a time. Make sense? Like this is a program that can be built incrementally. Okay, and so work on those increments. And if you get an error, don't try to just push back past it, because those building it on increments means that like it depends on you completing the previous portion first. So try to figure out what that issue is, because otherwise you'll just end up with a mass of spaghetti. All right,